welcome friends to another one of my videos. This one is in continuation with the PDF extraction series of videos that I have started to create. So in today's video what we are going to do is to try and extract data that is still tabular, but in a kind of a table which does not have horizontal lines or borders. So what that necessarily means is I will be using one of the example, or basically I'll be trying to extract data from uh, a tabular structure which is actually a table, but it does not have horizontal line separators, like I said. And to demonstrate that, I have used some of these sample documents which are available in public domain. These are drug formularies, and I have, in the readme file, I have pasted the URLs of all the files that I'm going to use in this tutorial. So to start with, the first one that I'm going to use especially for this video is going to be this one. So this file is a drug formulary document. Now, not getting into the details of what that means, it's basically a document of medical insurance related to, or is relevant to, medical insurances, where it indicates basically what kind of prescription drug falls in what kind of category, if it is subscribed or prescribed to a patient. It is mostly prevalent in markets outside India, like in US or UK. So not getting further into more details, the idea here is these documents, if you can see, this is a PDF document of close to almost 470 pages. But the information that we are interested in is the information which is of this nature. So if you see here, it is a table, but it does not have the rows and columns that separate as cells. So it does have some horizontal lines here, but it does not have those block kind of structure that we saw in the other video the last time, which was something like this. This was the sample table that I had the last time, but today we are going to use this this document and try to extract the information. One quick thing about this is, if you will see this document, like I said, it has 469 pages, and not all pages have tabular information. So it also has some other information, like you see this kind of index and also this preface and all these things. So we are not interested in that. All we are interested is to extract data which is in tabular format like this. Okay, so without getting into more details now, let's straight away get into it. So to start with, again, we are going to use Camelot, and I'll be importing the read PDF function from Camelot. So from okay, so this function, I mean, one quick thing is, the reason I renamed this is because eventually I also plan to use some other libraries which have a similar kind of functionality. For example, there is another library called Tabular. It also has a read PDF function. So at that point of time, I'll be using that read PDF as Tabular read PDF function. So I just want to keep it just to make sure, and just to make clarity, and I mean, basically it helps me to be clear in actually what function I am using. So okay, so now let's read this file. So I will supply the PDF path, which will be, or PDF file, which will be data. So it's under data, public domain formularies. Okay, and public domain formularies, and one table 3 column non-tabular, one table 3 column and non-tabular .pdf. Okay, so this is one of the files. Okay, this one, and now we'll use the read PDF function. And as we have seen last time, what happens is, when we use this function, it reads the information in these documents and gives us a list of, or set of tables as list. So what it will return is a list of tables. So if I do tables is equal to Camelot read PDF, and I'll pass the PDF file path. Okay, let's see, if I stop here, what happens. So basically I'm not going to pass any other parameter. Let's see what happens. So it does work, it has extracted. Let's see what's the data we have got. Okay, so now you can see we have got nothing out of here. So there is no tables as such here. It's a empty table list. Okay, so the reason for that is since we didn't pass any of the parameters, let's see the documentation what happens. So if you go to the documentation for read PDF, what it says is there is an attribute called pages, and if we do not pass any information to that attribute, it by default reads the first page of the document. In our case, the first page is this, which does not contain any tabular data, and hence we didn't get anything. Okay, so let's pass on the page, just a sample page that we want to extract, and let's see what happens. Okay, so what it says is in pages we have to pass comma separated page numbers. For example, if I want to extract 1, 3 and 4 page numbers, we have to pass it like this, or we can also pass it as a range. Okay, or we can say all. So when we say all, it will extract everything. Okay, so just to test, let's start by just sharing the first tabular page that contains this information. So let's try that. So I'll be using PDF file pages equal to 12, like it says. We have to pass it as a string in quotes. So that's what I'll do, and if I do that, let's see what happens. Okay, now you can see even after passing the pages, it is still not able to identify any tables. Actually, the reason for that is like we have chosen to extract information from a tabular structure which does not have cells. How Camelot works is it basically uses those cell borders and boundaries to identify the table. And there is another attribute. If we see the documentation, there is another attribute which is called flavor, which is responsible to identify whether the table is in a tabular structure or non-tabular structure. There are two attributes that we can pass as flavor. One is lattice, another one is stream. Now, I mean, of course, this is not just the only documentation that I've gone through. I have read about and played around with these flavors, and that's why I know that stream is the flavor that works with non-tabular data or data in this format, while lattice is the flavor which works with actual tabular data like this one, where we actually have the table cells and borders. Okay, so that's I mean, of course, you can go through all this documentation, and online also there is a lot of help around this, and you will be able to understand more on that part. And also, if you see the function note, it already is saying that there are two flavors, which is stream and lattice, and there are some parameters which only work with stream, and there are some parameters which only work with lattice. We'll get into those parameters later on when we will try to do a more complex kind of extraction, but for now I'll simply use the flavor as lattice instead of flavor as stream, sorry, instead of the default which is lattice. So let's try that out. So after pages, I'll pass stream. Okay, and this time it says we have extracted one table. So let's see what that table is. So tables 0, it is indeed a table of shape 41,3, so basically 41 rows and 3 columns. And if you want to see the data of this table, how we are going to do it is we'll call the data frame attribute, and you can see it is able to extract the tabular data. Split to right just to see and compare. It is able to extract this data here, and we are getting 3 columns as indicated here. Now, one thing to note here is although it's indicating or it's identifying the table, there is no way as of now for Camelot to identify whether this is a header or not. But still, having said that, we can see that the data is getting extracted. Now there is because this is a non-tabular data, there is a lot of cleanup and lot of things or cleanup activities that we need to perform in order to get the data in the correct format. For example, if you see here, in this case, the drug, although it's getting extracted, but we are getting these slash characters. So all these things and all this cleanup we have to do I mean later on, so I'll not get into those details right now. All I wanted to show is that this kind of extraction is possible. Yeah, that's about it. Now there is just one more thing that I wanted to show. This pages attribute has another entity where we can pass the value as all. So if you see here, the pages, we can pass a value all. If I do that, what it will do is it will scan the entire document, all the 469 pages, and it will extract the table, or basically it will extract the data from all the possible tables that it could identify. Okay, and it will be a part of this table list. So right now, where we see n is equal to 1, if there are more than 1 pages, it will show n is greater than 1. Okay, in fact, let's try to do it with at least a couple of pages. So this time what I'll do is I'll pass page number 12 and 13, and for that sake, let's pass 14 also. So if I do that, if there's one more thing that you'll observe, it will take a little bit more time, and of course if we scan the entire document, it will take the maximum amount of time possible. And my observation has been sometimes the extraction can take up to, if the document is really huge, it takes up to almost 10 to 15 minutes. Now this time, because we have passed 3 pages, each of these 3 pages have a tabular structure. We can see n is equal to 3, and if I check the first of the tables, so data frame property, so this is the first page, and if I check the second, this is the second page. If we go to page number 13, which is this one, you can see it is starting from this drug, which is also the first drug on this page. So yes, it is extracting the data, and for that matter, let's check the third page as well. So yes, it is extracting the data as we need. So yeah, this is a quick kind of demonstration of how we can actually extract the data from any non-tabular document which does not have a tabular structure, like with a proper cell identifier, or with a proper kind of vertical and horizontal lines identifying the table. Even in that case also, Camelot is really useful in extracting the data. So I hope this video was useful, at least for people who are looking to solve a similar kind of scenario. And of course it is something that we can explore more, and I'm also trying to learn more around this use case, and I would really I will really appreciate if you have some other viewpoints which you want to share in the comment section. We can have a discussion there as well. So thanks a lot for watching this video. Thank you. I'll be uploading some new videos and continuing in the same series, and hope to see you again in the next video. Thanks a lot.